Hey everyone, welcome back. Today we're going to be solving Leetcode 2337, move pieces to obtain a string. So this is a Leetcode medium problem and it's also a problem of the day. So yeah, let's begin. It's given that you have two strings, start and target, okay, both of length n, okay. Each string consists of only characters L, R, and then underscore, okay. So you cannot have any other character. The character L and R represent pieces where a piece L can move to the left only if there's a blank space directly to its left, and a piece R can move to the right only if there's a blank space directly towards the right. Okay. And the character underscore represents a blank space. Okay, you have to return true if it's possible to obtain the target. Okay, by moving the piece of the string start any number of times, otherwise return false. Okay, so here it says that you will have to return true if we can make start equal to the target, else we have to return false. That is the main question in this problem, and that's what we're gonna try solving. Okay, so let me just give you a brief understanding of the problem. So let's say that we have start as underscore r underscore r underscore r underscore, and then target as L, and then R and R. Okay, so if this is a start string and this is the target, the first thing that is given is both of them can contain only L, R, R, and the underscore. Okay, you cannot have any other characters different from this. Okay, and the second thing is that both of them are equal in length, so both of them are equal to length n, and we'll need to prove that we can move n number of times, how many ever number of times that you want, to achieve target. If you have to move start in such a way that we get the target. If you're able to get the target in the end, we have to return true. Else we have to return false. Okay, so this is a true or false question, right? Now let's identify all the false scenario in this case. Okay, let's forget the true case because that is very trivial. Let's try to understand what is a false scenario. Okay, what can be the possible false scenario? First, false cases. First is when length start dot length is not equal to target dot length. This would be a case where we would return false, right? If this is 3 and this is 6, in that case there's no way we can make start equal to the target, right? But the good thing is that we have been given what is the length, and length for both of them are equal. Okay, so that's a good thing. Okay, second thing, what would be the second case? Can we say that the pattern that we're forming, let's forget the underscore, let's form a pattern. For the string 1 it would look something like this, and for the string 2 it will look something like this. In the end, when we remove all the underscore and concatenate the string, this is a resultant string that we would get, right? These two are equal, right? But let's say that we have another character where it is R, L, and then L, and then you have target to be L, R, and R. Okay, if we concatenate this, we would get the string 1 as RLL and string 2 as LRR, right? If you see these two are not the same. So of course we have to return false, because there's no way you can form a string that is equal to the target. Okay, when both patterns are not same. Okay, and what is the third case? See, the thing is, one catch that is given in the problem is that left can move only towards the left and right can move only towards the right if there's a blank space. Okay, if there's not a blank space, then you can't move it. By that, what I mean is you cannot move L over here. You can move L over here, L over here. Oh, sorry. My bad. L is to the left. You cannot move L. Let's assume that we have a L over here, okay, and then you have another L over another R over here, okay. You cannot move this L directly to this point, right? You can move this L to the left because there's a space over here, right? So you can move left and right only when there's a space, and you can move left only towards the left and right only towards the right. You cannot move left towards the right. This is an exception where you cannot move the left towards the right. Okay. Similarly, the same thing for right. You can move right only towards the right, not over here. You cannot move this, and also you cannot move it towards the left. For obvious reasons, because you cannot move the right part towards the left. Okay, that is another condition where we can say that we string cannot be made equal to the target. Okay, let's look into that. Okay, perfect. So let's say that we have L and dash. This is my str1. Let me mark it as S, and then my target would be dash and L. Okay, so our idea is to achieve target by moving L, right? Now tell me something. According to the constraints of the problem that is given, that L can move only towards the left and right can only move towards the right, can I make a movement for this towards the right? I cannot, right? This is a L. So L can only move towards L, it cannot move towards the right. But if you see in the target, your left is on the right side, okay, but the left in the string is on the left side, so you cannot move this towards the right? So this is not possible, right? Similarly, if you consider L like this, and then you have L over here, this is string and this is target. In this case, in this case, we can move this L towards the left, right? Because this L is the starting of the target, and since we found the L to be present in the string, we move this over here. This would return us true. The same case for R as well. You have R over here, okay, and then in target you have R like this, okay. Right can move only towards the right, it cannot move towards the left, right? So if I try to move this towards the left, this would throw us an exception, so this is not possible, right? This would return us false. Okay. Similarly, we can consider something like this, where S is like this and then T is like this, okay. Here we can move our R towards the right, because the first thing is we can move the right pointer towards the right, and second thing is that we have a blank space where we can move the right pointer to. This case is valid, okay. So now I need to say that if my okay, so let's say assume this to be I, and this, in this case for L where we have a failure, let's assume this to be I and J. Can I say that whenever my J is greater than I cannot move my left pointer towards the right? I is nothing but the pointer for the string 1, and J is nothing but the pointer for target. Okay. Now, can I say that when my J is greater than I cannot move my left towards the right, which means that the string is not valid, it will not result in target, okay. Same thing with left. If I assume this to be I and this to be J, okay, if my J is less than I, right, J is where it is a pointer on the target and I is the pointer on the string, right? If my j is less than I, visually if you see I is greater than j, we can say that hey, we cannot make a string that is equal to the target because we cannot move right to the left, right? This is another major point that we need to note. Okay, when I is greater than, sorry, when j is greater than I, j is greater than I for left, and I is greater than j for right, we will break, we will return false. What is the next case? Next case is very simple. See, the thing is, since both of the elements, both of the strings have the same number of length, right? If you have to form string 1 to target and they have the same length, in that case, we can return true only when we have processed through all the elements of the string. Right. By that, what I mean is, let's take L R. Okay, and you have L over here, and then you have R, and then something like this. This is string. This is target. No, sorry. This is target, and this is string. Right. If I hold two pointers over here, this is where it starts. If I hold two pointers over here, okay, so this pointer, what's gonna happen is it's gonna so yeah, this is target, right? Okay, perfect. So I have reached an empty space, so let me go to the next one. See, in this case my this is I and j. In this case my j is greater than I, right? My j is greater than I. Can I move this towards the left? Yes, I can. Right, yes I can. Right, right. Just a second, have I made a mistake? Ah, sorry, I made a mistake in naming. This is I and this is j. Yeah, now it makes sense because this is the target and this is string. Right. Now I have my I over here, okay, and I moved my I so that I reach a character, L or R, whatever it is, I reach a character, and I'm checking if my string of I is equals to the target. If it is equal, I'm checking if I is greater than j. If I is greater than j for L, which means that it's valid. Remember that we will only break when j is greater than I, right? But in this case, I is greater than j, which means that there is a space for left to move towards the left, such that it can form the target. That's what it means. Okay. Now, what's gonna happen is, again, this is gonna go to this, and this is going to come here, and then this is going to reach a character. Now, in terms of R. Okay. Now, what is the condition for the right character to break? The condition is I is greater than j. Okay, in this case is I greater than j. It's not, right? It is j is greater than I, right? Visually, if you see over here, j is greater than I, right? So this is also valid, which means that I have a space where I can move my right such that it forms a target. Okay, now what's gonna happen is this is gonna come out, this is gonna come out, this is gonna come out, this is gonna come out. Now I can say that since both of them have come out, which means that both of the string has been processed in such a way that my start has been start is equal to the target. That's what it means, right? But let's take an example where you have str1 as L, and then space, and then space over here, and then you have L over here, and space, space, space. Target. Here what's going to happen is if you compare these two, this will actually start from here. Yeah. If you compare these two, for target I've reached a character, okay. So for string I've not reached a character, okay. This is my I and this is my j, right. What is the breaking condition? If j is greater than I, okay. Okay, this is actually a valid case. Let me do one thing. Let me put this over here. Okay. My j would come here and then it would break, it would come here, it would break, and then it will come here. My j is greater than I, okay. When my j is greater than I, what does that mean? When my j is greater than I, can I say that forming a string is not possible, because I'll have to move left towards the right for for me to make it equal to the target, which is not possible because left does not move towards the right. It should and always will move towards the left only when there's a space, right. In this case, if you observe, we're not even going through the entire string, right. We're just breaking it off, right. We're not even going through the entire string, we're breaking it off, which means that the entire string has not been processed, because there is some exception that has been that has occurred, which is causing the string 1 not to form target, okay. So if you see over here, the last point is, if either of the string if either of the pointer is not equal to length, then we break. Can we think of any other condition apart from this which would give us a false? Let's think about it. We have covered the scenario where it's not equal to the length, and the second scenario where both the patterns are not the same when you concatenate them. Third is where, again, I told you, where we cannot move left to the right and the right to the left. And fourth is where we're not iterative to the entire string. I don't think there's anything else, because we have covered every other scenario. So I would suggest that whenever you're solving a question which is asking you to return true or false, always try to look at the false conditions first, because true is straightforward, false is where the trick lies, right. So we have covered all the false cases. Now let's try to handle it in terms of code. This is false cases. Let's try to handle it in terms of code, okay. Let me open up the code. Perfect. Okay. I will explain you the logic through the code. We have covered the logic almost entirely, but how are the pointers moving? That will explain you with the code. Okay. So it's very simple. Let me initiate a pointer I equals to 0, okay, and then pointer j equals to 0. So what this is going to do is, this is going to tell me the position of I is going to tell me the position of start, and j is going to tell me the position of target, okay. So now I'm going to apply a while loop. Okay, let me also take the length n equals to start dot length. Since both of them are equal, I don't need to compare the length for target, but if the length is not equal, that would be our first condition, as we have already covered it in our fail scenarios. So if the length is not equal, we're going to return false directly. We're not even going to enter the loop, okay. Now while I is less than n or j is less than n, okay. So this is going to come in only when I is less than n or j is less than n. If any one of the condition is true, it's going to come in. Why? Because the reason I'm not adding a AND operator instead of OR operator is because, the reason I'm not adding a AND operator here instead of an OR operator is because this condition will be handled inside the code. If you remember, the last scenario that we saw was that if either of the pointer is not equal to the length, then you're going to break it. So that is what we're going to handle over here inside. Okay, so first let me do one thing. Let me run a while loop again. So here what I'm going to do is I is less than n. Okay, well, I is less than n, and start of I equals to an underscore. Then what I'm going to do is I plus plus. Okay, the reason I'm doing this is because, see, with the help of, let me take this example. Okay, the reason I'm doing this is because with the help of pointers, I'm trying to maintain the relative position, right? Okay, that is the main point of the pointer. I'm trying to maintain the relative position of each of the characters. Okay, and in that relative position is where I'm checking my conditions for returning false. Okay, when I'm so the thing is, I don't even have to consider underscore, right? Because underscore is basically an empty space. So when I know that there's an empty space and I have a character to move, that is good enough, right? So by that what I mean is, see, when I found a empty space over here, I don't have to do anything. I can just go to the next character which is not an empty space. Okay, and then compare these two. Right, now after that, after compare again, I'm gonna go to the next character which is not an empty space. Similarly for target also, we would be going to the next character after empty space and making sure that these two's position are in a place such that they can be, they can form a target, right? These two are in such a position that it is good for me to form the target, right? That is what I need, right? So now the same thing I'm going to do. Okay, wait, this will be dot caret of I. Okay, I plus plus while j is less than n, and target dot caret of I equals to underscore. I'm going to move j plus plus. Right, so we have moved our I and j to the point where we've reached an element which is not underscore. Now is where our validation comes in. What is the first one? Let's handle the first one later, but let's go from the last. Let's handle this first. Okay, so basically what I'm going to do is I'm going to check if I equals to n or I j equals to n. What I'm going to do is I'm going to check if I equals to n and j equals to n, which means that we have processed successfully and I can return true. Else, which means that one of them has reached the length but the other is still pending, right? That's what it means. So I can just return false. Perfect. So we have handled this condition successfully. Let's come to the next condition. Okay, now this condition we're not going to handle it because it's already given that both the lengths are equal. Now when both the patterns are not same, by that what I mean is, since we've reached a point where we have a character, can I say that if my start of I is not equal to target of j, can I say that when my start of I is not equal to target of j, that is when I have L over here and when I have R over here and both the R over here and both the pointers are standing at this point. After iterating through this thing, it's standing at this point. Can I say that if these two are not equal, I'll never be able to, so I have string 1 and then target. So I have L and R over here. now it has iterated and it has come to a position where the characters it is equal to L or R, right? Now my I is standing over here and my J is standing over here. Now if these two are not equal, can I say that this is never going to form a string? How can I form a string with this, right? It's basic. I can never form a string. So this is a very trivial condition and we're going to return false. What else are the conditions? Or can I say that, or if my always make this mistake, it's not equal to, it's dot caret of I, caret of J. Okay, or start dot caret of I equals to L, character L, and what? And if this condition is if this condition is true, in that case I can return false, right? And and J is greater than I, which means that I can return false. Similarly, we'll do the same thing for R as well. Start dot caret of J equals to R and what is the condition? And when my I is greater than J, then I can say that it is not possible to move towards the left. And I greater than J, I can't move towards the left. This is the condition where I can return false. So simply I'm going to return false. So this would cover our this condition, let me erase this. This condition, this condition and also these two conditions. Now have we covered all the false cases? We have. Perfect. So now what we're going to do is we're just going to increment our I and J, I plus plus, J plus plus, right? So it's gonna find this thing, and if you've reached a character which is not equal to underscore, it's gonna go through this entire condition. If not, it's just gonna increment I and J until it finds this thing, right? Makes sense. Perfect. Now if any of this occurs, I'm going to return false. If not, I'm going to return true. I'm going to say return true. Perfect. Let me run this code. Okay, I got a runtime error because index. Sorry, I was supposed to be iterating through J. Perfect. Okay, I got an error though. What is that? R, okay, and then R over here, and all the other conditions passed. Perfect. Okay. Sorry. I'm checking I, not J. Not J. Perfect. The thing is, I'm supposed to be checking I, but there was J over here, and that's the reason we got the error. But now all the cases have been passed. Let's try to submit our code. Perfect. Perfect. So this would give us the complexity of n. It'll be actually O of n plus m, and since uh, both of them are equal, so it'll be O of n. Yeah, perfect. Thank you so much for watching. Stay consistent. Thank you.